Hello everyone, this is the first lesson recording for IM1, November 13th, 2020. What are we doing today? We are going to be exploring more scatter plots. We're going to talk about the association shape, association strength, and line of best fit. Quick announcements, quiz number 5 retake. You took a quiz last time, and if you're not happy with the result, you can do a retake on them. In order to do that, you need to arrange a time for us to go over your quiz together, and then you can take the retake next year. Any work you do now will not only improve your grade, but improve your learning so that you can do better on the unit test that's coming up. That's going to be in early December and on the semester final. So it's not just, the quiz is not just a done deal. So I would really like those people who did not do so well to contact me so that we can take the retake. Now, last lesson, we talked about association, okay? And that describing association, it can be described in terms of direction as being positive or negative. And we talked about that in the last lesson. And we can also describe them in terms of shape, linear or nonlinear. We're going to talk about that right now. And then later on, we'll talk about the strength, being strong or weak. So looking at this, this is a quick review from last lesson. Okay, and so in preview, private chat, which graph shows positive association? Remember, positive association means it's as if it's increasing. If the data points, the trend is increasing from left to right. So as you go from left to right, what do the data points do? It looks like it is increasing, or is it decreasing, or what? Okay, so positive is when it is increasing, negative is when it is decreasing, or when it looks like it has a negative slope. So which graph shows a positive association? This one, because it's increasing from left to right. As it increases on the x-axis, okay, the y-axis, the values also increase. So you end up with positive result, positive slope. B is actually decreasing, right? So which graph shows negative association? B is decreasing as D. D is also decreasing. So B and D have negative association, while as C, I do not, it looks like the dots are random, so it will be no association. Okay, so now let's talk about the shape of associations. Remember, all these little blue dots, they represent just someone or something's data. But when you just see one data, it doesn't tell us much. But when you see many data, you can start to see a trend that you can use to generalize. So do the points follow shape of a line? So when you hear about linear versus non-linear, I need you to start seeing that there is in the word linear, there is a word line right there. The linear comes from the word line, or they are derived from the same root word. So you need to be, linear means a line. Okay, does it look like a line? Yes, the first one looks like a line. Does number 2 look like a line? No, it looks very random, so there's no association. What about 3? Does it look like a line? No, it actually looks curved. Okay, if I was to draw sort of a trend, it looks curved, while as number 4, it looks like a straight line, so we will call that linear. So 1 and 4 are linear, 3 is non-linear, and number 2 is no association. So I want you to tell me in private chat now, which graph shows nonlinear association? Remember, nonlinear means, linear means a straight line. So nonlinear means something that is not straight line or curved. So which one looks like it's nonlinear association? A, B, C, or D? It's B, because B looks like it's curved line, while as A looks straight and D looks like a straight line. Which graph shows linear association? A and D. While as C, I would say no association on that. So at this point, you're working on some Desmos activity. You're working on card number 1 to 5 of Desmos activity. So please find the link and then do the activities. You can find the link from Canvas. This is the first card from Desmos. Now we're going to be talking about strength of association. So far we've talked about the direction being either positive or negative, and then we talked about shape being either linear or non-linear. Now we're going to talk about strength being either strong or weak. So before we start, let's try to get sense of how strongly two variables are associated. So one technique for this is to try to draw an oval around the data. So all these green dots represent some data. Draw the smallest oval you can around the data in this scatter plot. Do the data appear to be associated? If yes, is it positive or negative association? So let me draw the oval. Remember, ovals look like this. This is an oval. This is an oval. In fact, even a circle is a special type of an oval. Okay, so let me just undo that. Okay, but I need to draw an oval around all the data. So if I was to do that, maybe my oval will look something like this. That includes all the data points. Okay, so that's my oval. Okay, looking at this, does it look like there is association? Does it look like those points are randomly placed, or does it look like there is a definite trend? It looks like a definite trend to me. Now, is the trend increasing from left to right, or is it decreasing from left to right? It's increasing, right? As x is increasing, the y is also increasing. So they're increasing, or you can also think of it as having a positive slope. If I was to draw a line through it, I would say this has a positive slope. So this is a positive association. So I would click on that. Okay, let's go on to the next card. Draw the smallest oval you can around this set of data in the scatter plot. Okay, let's do that first. That makes it a little bit more challenging, but circle is an oval. Okay, so there we go. All right, so does it look like there is an association? Okay, it's kind of hard to tell, but I would say if I had to choose, let me just draw yet another more different oval. I would say most of it falls in points like so. Okay, so there is an outline here, but generally it's forming like this. And so there are no points here, there are no points out here, so there seems to be some sort of association. Is it positive or negative? If I had to choose, I would say this is negative. So I would say it's a negative association. Okay, or you could say, I don't know, that looks pretty random to me, or you could even say it's a no association. All right, what about this? Draw the smallest oval you can around the data. That makes it easy. So here we go. All right, there. So is there association? Yeah, there definitely tend to be a trend, right? It's not, the points are not all over the place. So there is an association. Is a positive association, negative association, or no association? If I had to draw a line through it, I would say it's going down. So I would say it's a negative association. What about this? Okay, so I need to draw a oval around it. Okay, so then I am going to try to draw something like drawing most or all of the points. Okay, so I missed that point. So maybe I need to revise that. Okay, so that's my oval. Is there association? Yes, I would say there is an association, and it's a positive association. Okay, because it's as if the trend is going increasing from left to right. Okay, so now strength of association. They've actually drawn the circle ovals for us. Which graph has the strongest association? How do the ovals help you decide the strength of the association? Well, the third one and the first one, the points were very definitely going through some sort of a trend. It was very clear. Whereas the second and fourth, it wasn't as clear. You could even say they look a little bit more random, right? So comparing them, I would say the first and the third have strong association, while as these two are becoming more random. So they do have association, but their strength, the association is weak. It's not strong. Okay. Okay. So let's get back to our slide. Then let's summarize what we figured out. That the strength of association, the stronger the association, then the data is less scattered. So here the data are more scattered everywhere, while as the first and the third, they are more clustered around, say, a straight line, right? So this one has a strong association, this one has strong association, while as the second and the fourth one, they have weak association. So data is less scattered, and long and narrow oval will be a stronger association, while as a weak association data is more scattered and there is a wider oval. All right, so that's strong, stronger, and weak or none, and weaker or none. All right, so I want you to answer in private chat. Tell me which graph shows the strongest association. Given these 6 graphs, scatter plots, which one is the strongest association? I'll say F, because if I was to draw an oval around it, it's the narrowest and looks less scattered. What about which one is the weakest association? Well, the weakest one I would say is A, because it looks all scattered about, possibly even B and C. So A is definitely the weakest, and possibly even B and C are weak. Okay, so then when we talk about linear association, remember linear means the shape is straight line. We can present the data with a line of best fit. So if you have this scatter point data, then you can almost draw a line, and we call that line of best fit. Okay, and so card number 6 to 7, can you complete those? So this is card number 6 of Desmos, selecting the line of best fit. Which graph shows the best line of best fit for the scatter plot? So when we're talking about line of best fit, we want that line to follow the trend of the data. Okay, so looking at A is going exactly opposite direction, right? And B, it's close, but which is the best one? I would say C, because it is following the points the best. Okay, let's look at the next card. Which graph shows the best line of best fit for scatter plot? A, B, or C, D. Okay, so looking at these data points, okay, which line follows the trend of the points? I would say it's the first one. For the 3 choices that you did not select, pick one of them and explain why you didn't pick them. Okay, so you could pick any of them and you can explain. So summarizing what you should have discovered, a good line of best fit is that a line that follows the trend of the data. Okay, so in this case, the last one is not following the trend of the data. It's going opposite direction to the data direction, right? And then secondly, the approximate equal points above and below the line. So if I was to pick this one, there is 1, 2, 3, 4, 5, 6 points below the line, but there are a whole lot more above the line. So that's no good. So I'm going to say B is not a very good line of best fit. Okay, and then it needs to go through as many points as possible. That makes C no good, And so A is my final choice. So